Hey, welcome back everybody. This will officially be part 2 of our arithmetic sequence 1.2 video series. And I want to take a minute here and reflect on the last video. Remember, we ended it with the necessity for a formula. We call it the Nth Term Formula that finds terms of the sequence, in case somebody asks me to find one that's way out there, like the 50th or 150th term. And that's where we kind of left off. All right, so I'm back on the lesson notes here, and I've got a formula for you here in a box, and I know it may look complicated, so let me just explain what this says. Finding a formula for the nth term of an arithmetic sequence. This is a skill that we have to pick up. Now, let me read through this and sort of nail this language down and make some sense of it. The nth term of an arithmetic sequence with the first term f of 1. Remember, f of 1 is just the first term. So when you see a sequence like this one right here, that is f of 1. Okay, it's that number. They can't use that number because that's not generic enough. Remember, this has to represent every arithmetic sequence that there is. And remember, it has to be an arithmetic sequence to use this formula. Okay? And the common difference, d, is right here. In other words, I personally, when I write this formula, I like to move d out front, because when we distribute left to right usually, and we don't think of it. This always looks kind of backwards to me. But this formula will give me an nth term. So, okay, so what do we need to make a formula like this? We need the first term, and we need a common difference, and that's all we need. And a little note here, and this will become important in another video later. This is called the explicit form. The explicit form can tell you any term of the sequence you want anywhere. Okay, that's what's important about that. All right, so let's go down here to example 5, and we'll work this out. And I'll update these notes after the video. Okay, example 5 says, write an equation for the nth term of the arithmetic sequence. Okay, an equation for the nth term, or you can call it an nth term formula, they're the same thing. So what they want here is a formula. And let's go to work on this and see what we can come up with. So we got negative 12, negative 8, negative 4, and 0. And let's go to the scratch pad to do this one. All right, so let's write the sequence down. Negative 12, negative 8, negative 4, and 0. Is this sequence is increasing, right? It's going up because we're going from negative 12 to negative 8 to negative 4. I don't know if you realize it, but it's going up by 4. But just in case, we'll find the common difference by hand here. Anywhere in here you want to look, pick the easiest spot, 0 minus negative 4. There's that positive 4 you needed. Your first term, f of 1, is negative 12. Remember, those are the two things I need. We're going to plug it into the formula. F of n equals f of 1, which is negative 12, plus n minus 1 times 4. That will predict terms of the sequence. All right, now the truth is, most of the time this thing's going to get simplified. So I'm going to simplify this one and try to do a good job with this. All right, that 4 needs to be distributed to the n and the negative 1. So that would look like this. Plus 4, here we go there, right? N, then he's going to go there. Minus 4. And I'm going to have to make me a little box here for the finished product. Maybe I'll put it right here because I'm running out of space. All right. So we're going to now combine this negative 12 and the negative 4. And our finished formula would say f of n equals 4n minus 16. All right, now, I'm going to spend a minute or two on this one because it's important that we do this little test right here. Remember, this thing is supposed to give me these terms in this sequence. And if you put 1 in, does it work? You got to test it. Put 1 in for n. 4 times 1 minus 16 is negative 12. Yes, that worked. put 2 in for n. 4 times 2, it's 8, minus 16, yeah, that's negative 8. This seems to be working, so we have found an nth term formula. All right? Now I want to demonstrate the next part of this is how do you use it. Now, like I said, I'll type these notes up and write this in after this example. It says, find the 51st term of the sequence. Now, that would previously be pretty hard. I'd have to add 4, add 4, add 4, and keep on going, right? But now we know that we can use our formula that we just created. And let's see, let's clear this out and go to work on this thing. It says, find the 51st term. So, 51st term looks like this. Let's write our formula again. F of n is 4n minus 16. To find the 51st term, we plug in 51 for n. So we're going to find f of 51, which is 4 times 51 minus 16. Notice I'm using that function notation that we talked about, right? And when you compute this, you're going to get 188. So the 51st term is 188, right? Or you could write f of 51 is 188. All right, now let's come down here and talk about another example. And I'm going to do 3 of these all together. It says, write an equation for the nth term of the arithmetic sequence. This time I'm given 11, negative 15, negative 19, negative 23. And this one appears to be going down. So let's go to the scratch pad and work on it. I'll write that in there real quick. So now we've got negative 11, negative 15, negative 19, negative 23. We need the nth term formula. So we're going to write, well, we need to find some things first, don't we? F of 1 is your first term. It's negative 11. You need to calculate D, common difference. So that's negative 15 minus negative 11. And that gives me a negative 4 this time. Now you can pick any two to find D. It could have been negative 23 minus 19, or negative 19 minus negative 15. Any of those places work. I always pick the smaller numbers, the easiest place to pick them. All right, so now we're going to write our formula. And we're always going to simplify these. So we got negative 11. You know what? This time I'm going to put D out front, like I said earlier. Minus 4 times n minus 1. This is at D, right? He could have been over here, but by commutativity, we can move him around. It just looked awkward putting a plus here and a negative 4 over on that side. All right, so I'm going to simplify this. Negative 11 minus 4n plus 4. Don't forget to change those signs. Negative times a negative is positive. Oops, better change it to a 4. And what do I get? Negative 4n minus 7. And there's your nth term formula. He can predict any term they're asking for. And let's go here and see which one they're looking for. They want the 15th term. So it's a two-step process. First, build the formula, then make the prediction. All right, so we want f of 15. That's negative 4 times 15 minus 7. Last time I checked, that's negative 67. All right? Now, if someone's asking for the formula, that you want a nice simplified formula like this, and you can always see that common difference out front. It's kind of nice. If you're just using it to make a prediction, you could have made that prediction from right here. You could have plugged in n from right there and not even done the simplifying step. Okay, so maybe I'll run into one of those next. Oh, good. The third example is a good one, and this video is going to be a little long because of this one. I don't want to make a separate video just for this, so let's go ahead and do this one. All right, this arithmetic sequence is in tabular form, and it has an issue. Okay, so what we need is the first term and D for this nth term equation. They're not asking for a specific term; they want the formula. Okay, what predicts these terms? Now, an inspection really quick gives us that we know D is 5, right? 8 minus 3 is 5. 13 minus 8 is 5. 18 minus 13 is 5. So D is 5. The problem is I don't have the first term. I don't have f of 1. All right, I have f of 3. So I need to back it up. And that there's more than one way to do this. I'm going to show you what I think most of you would do, and I think it's a good strategy. All right, so real quick, the sequence is doing this, right? It's going from negative 2, 3, 8, 13. Okay. I'm looking for something. There we go. All right, so the sequence is doing this. F of, well, let me start over. I want to do it a little bit different than that. I don't want to use, I want to start right here in the middle. All right, so F of 3, we know is negative 2. That's what they're telling me. We know the next one down there adds 5, right? And so F of 4 is 3. F of 5 is 8, and so on, right? But we need to go backwards to find that F of 1. So F of 2 means I need to subtract 5 from this negative 2, and I get negative 7. F of 1, subtract 5 again, I get negative 12. So now I've found my first term. And I can write my formula. I know D is 5, right? So I'm going to write F of n is negative 12 plus 5 times n minus 1. Now I know I'm reversing where D goes, and I'll correct that in just a second for you. I'll give you another formula. F of n equals negative 12 plus 5n minus 5. So I'm getting 5n minus 17. All right, does the formula work? It has to work or it's wrong. It needs to give me these terms in that order. Plug in 1 for n, 5 minus 17 is negative 12, yeah. Plug in 2 for n, 10 minus 17 is negative 7, yeah. 3 for n, 15 minus 17 is negative 2. All right, and so on. It is working. It does give us the sequence. Real quick before this video is over, I want to show you one thing I want to clarify in case I get a bunch of questions about this. The formula says that you need the first term plus n minus 1 times d, right? What I'm doing, and I've done it twice now without telling you really a whole lot about it, is I put d out front like that. And honestly, if you want to do that, that's really okay. Because I guess that's just a habit I distribute from left to right, and it just looks neater this way to me. I don't know why. I guess I write left to right, but that just looks awkward when I'm working the math out. So to me, this is the real formula that I use. They are the same thing, because remember we have commutativity and multiplication. Order doesn't matter. So you can move this d out front. And if d is negative, change that to a minus, and so on. So I know this video got long, but I think it's covered most of the bases for this part 2. And be sure to watch it, this rest of the series, and watch this one again if you need to. All right. Good luck, guys. I'll talk to you in the next one.